Hello and welcome to a new video on IGCSE Physics Classified Paper 4. In this video, we shall be discussing the topic of electric field. Describe what is meant by an electric field. State what is meant by the direction of an electric field. So this question is very popular. It appeared in 3 different exams: June 2020, November 2016, and November 2019 in paper 4. And it appeared exactly in the same manner. So you should definitely know how to answer this question, and you should understand the definition of an electric field and its direction, because it's a very popular question that is likely to come up in your exam. So an electric field is a region, a space, in which a charged particle experiences a force. So what if this question was gravitational field? So if this was gravitational instead of electric, it would still be a region in which a mass, so an object that has a mass, experiences a force. So it's the exact same definition. So any field is a region in which something experiences a force. Now, if it's an electric field, then this object has to be a charged particle. If it's a gravitational field, then this object must have a mass. If it's a magnetic field, then this object must be a magnet. But in all cases, a field is a region in which something experiences a force. So I want you to understand the difference between the different types of fields. In double I, we are told state what is meant by the direction of an electric field. So this is specific to electric fields. You should understand that if an electric field is in this direction, for example, this means that any positively charged particle is going to move in the same direction. So the direction of an electric field is the direction of the force experienced by a positively charged particle. Not any charged particle, but a positively charged particle. So what if we had a negative charge? If we had a negative charge and the electric field was moving to the right, so the negative charge would experience a force to the left. This is slightly advanced for your level, but just understand that the positive charge moves in the same direction of an electric field. And if you're expected to state what is meant by the direction of an electric field, this is the direction of the force experienced by the positively charged particle. Figure 11.1 shows a positively charged sphere. On figure 11.1, draw the pattern of the electric field in the region around the positively charged sphere. Show the direction of the field with arrows. So if you have a charged sphere, you should know how to draw an electric field surrounding it. You should know that it is radially outward. So it looks like the sun in a way, and the arrows are always pointing outwards, because we're going to get other questions where the sphere is negatively charged. And in this case, we also have these arrows, but they're pointing inwards. And when you're drawing the arrows, they must be equally spaced. So you cannot, so this is a good example. This is a good example. But for example, if you have a positively charged sphere like this, you cannot draw the lines like this, for example. You cannot draw arrows that are close to each other and arrows that are far away from each other. The distribution of the arrows must be even. So in this case, we have arrows pointing outwards, and they are evenly distributed around the sphere. So the arrows must be evenly distributed or equally spaced and pointing outwards. Of course, this is not something that you need to write in the exam. This is just a note that I'm leaving here so that you understand that when you draw, the arrows must be equally spaced and they must be pointing outwards. You don't have to write that down, of course. Figure 8.2 shows a small black circle that represents a positive charge. Draw the pattern and direction of the electric field in the region around the charge. So this is the same exact question again, except that here we have a small circle instead of a big sphere. And all we have to do here is just draw 4 arrows like this, for example. As long as they're equally spaced and pointing outwards, this would be a correct answer. At least 4 arrows, not less than that. Again, the same question again. We have a positive charge, so we're going to just draw 4 equally spaced arrows pointing outwards, like this. See how often the question is repeated. They really like to bring this question in exams, so take a mental note of it. Now, in this case, we have a negatively charged sphere. So it's, again, the pattern and direction is exactly the same, except for the fact that it's pointing inwards. So they have to be equally spaced again, and at least 4. And they have to be pointing inwards. This is the same question again in a different exam. We have a negatively charged sphere. So we have to draw 4 equally spaced arrows pointing inwards towards the sphere. These comments on the right here, these are just for you to understand. You definitely do not need to write them in the exam. So this is slightly different. We have 2 parallel conducting plates connected to a battery, and we want to draw 5 lines, not less than 5 lines, to show the electric field pattern between the 2 plates. So unlike the sphere, here the electric field looks slightly different. Of course, you should understand that this is the positive terminal of a battery. This is the negative terminal of the battery. So we expect to have positive charges here and negative charges here. And we expect the electric field to move from the positive to the negative. So we expect to have 5 arrows that are also equally spaced, moving from the positive to the negative. This is how it should look like. And definitely the arrow should be pointing from left to right. So the head of the arrow should be towards the right-hand side. Next, we move on to the topic of conductors and insulators. Explain in terms of their structures why the metal wire is an electrical conductor, but the plastic stand is an electrical insulator. So you should definitely understand the structure of conductors and the structure of insulators and how they're different from each other. It's a very simple idea. Basically, if we take any object and we assume that these are the atoms of the object, we have, if it's a metal, if it's a conductor, we have free moving electrons that can roam around inside the object. So any conductor has free moving electrons. This is the main difference between metals and non-metals, or conductors and insulators. Of course, metals are conductors and non-metals are insulators. So you should always know that metals have free moving electrons. You cannot say while non-metals don't. Not just write here, don't, like this, and then leave the answer like this without writing the second part. Because if you leave it like this without writing this part here, this suggests that metals have free moving electrons while non-metals don't have free moving electrons. They don't have electrons to begin with. So the nicer way to say this, the more correct way to say this, is that they have free moving electrons, the metals or the conductors, but in insulators, there are electrons as well, but they are fixed in position. They are not free to move. This is the difference. So both of them have electrons, of course, but in conductors, the electrons are free to move. However, in insulators, the electrons are fixed in position. In terms of a simple electron model, describe the differences between conductors and insulators. This is the same exact question again, just with a slightly different wording. Again, conductors have free moving electrons, while insulators have electrons that are fixed in position. The metal sphere S is an electrical conductor. The plastic thread is an electrical insulator. Explain this difference by referring to the structures of the two materials. Again, this is a different wording of the same exact concept. A conductor has free moving electrons, while electrons in insulators are fixed in position. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.